The air we breathe, the very essence of life, has become a subject of intense debate, a source of both anxiety and uncertainty. Carbon dioxide, a colorless, odorless gas, essential for life on Earth, now carries the weight of a looming threat, a harbinger of environmental catastrophe. The narrative is pervasive. Carbon dioxide emissions driven by human activity are inexorably warming our planet, pushing us toward a climate tipping point. Glaciers will melt, sea levels will rise, and extreme weather events will become the norm. The future, we are told, is one of scorching temperatures, devastating droughts, and mass extinctions. This narrative, repeated with unwavering certainty, has permeated our collective consciousness, shaping our policies, our choices, and our very perception of the future. But what if this narrative, compelling as it may seem, is incomplete? What if the relationship between carbon dioxide and our climate is far more nuanced, far more complex than we've been led to believe? What if the very foundation upon which this alarmist narrative rests is built on shaky ground, on assumptions that don't hold up under scrutiny? The dominant narrative surrounding carbon dioxide has painted a picture of a planet in peril, a world teetering on the brink of irreversible climate disaster. We are bombarded with images of melting ice caps, raging wildfires, and extreme weather events, all presented as irrefutable evidence of humanity's destructive impact on the planet. The message is clear: we are to blame, and drastic action is needed to avert catastrophe. This message, amplified by the media, by politicians, and by well-meaning activists, has instilled a sense of urgency, a need to act now, to make sacrifices, to embrace radical solutions. But has this sense of urgency, this fear of impending doom, blinded us to the bigger picture, to the complex interplay of factors that shape our planet's climate? Have we, in our haste to assign blame and find solutions, overlooked crucial pieces of the puzzle, evidence that challenges the prevailing narrative? To truly understand the relationship between carbon dioxide and our world, we must embark on a journey through time, delving into Earth's long and tumultuous history. We must examine the geological record, the ancient archives of climate change, preserved in ice cores, tree rings, and ocean sediments. These natural records hold the key to unlocking the secrets of Earth's past climates, revealing the ebb and flow of warming and cooling periods that have shaped our planet over millennia. By studying these ancient climate records, we can begin to disentangle the complex web of factors that influence Earth's climate, from volcanic eruptions and solar activity to the subtle shifts in Earth's orbit and the intricate dance of ocean currents. We can begin to see that climate change is not a recent phenomenon, but rather an inherent characteristic of our planet, a dynamic system in constant flux. Studies of these ice cores reveal a fascinating pattern. CO2 levels and global temperatures are closely linked, but not in the way we might expect. Instead of CO2 leading the charge, it often follows temperature changes. When our planet warms, CO2 is naturally released from the oceans, like a carbonated drink fizzing when it heats up. Conversely, during cooler periods, the oceans absorb more CO2, acting as a vast carbon sink. This natural cycle of release and storage is a fundamental characteristic of Earth's climate system, one that has played out over millions of years. By examining these ancient records, we can see that CO2 is not the primary driver of temperature changes, but rather a participant in a much larger, more intricate dance. This understanding challenges the simplistic narrative that CO2 alone dictates our climate, urging us to consider the myriad factors at play. As we continue our journey, we must keep this complex interplay in mind, seeking a deeper, more nuanced understanding of the forces that shape our world. This is not to say that human activity has no impact on our planet. Environmentally, it's undeniable that we have left our mark on the Earth, from the sprawling cities we build to the vast agricultural lands we cultivate. However, the question is not whether we have an impact, but rather the nature and magnitude of that impact. Is carbon dioxide truly the climate-controlling villain it's been made out to be, or is it but a small actor in a far grander play, a play with a cast of characters and a plot far more intricate than we can currently comprehend? Let's ask a simple question. If the atmosphere is represented by 10,000 marbles, how many marbles would be CO2? How many? 4 marbles. 0.04% of the atmosphere a trace gas. Do you really think this could be the solution for regulating the temperature on Earth? Our goal is not to deny climate change but to understand it, to see it in its full complexity, and to base our decisions on sound science, not fear-mongering. Let's take a step back in time, to the 17th century, a period of profound scientific upheaval and discovery. In this era, one man stood at the crossroads of science and dogma, Galileo Galilei. Known as the father of modern observational astronomy, Galileo's work laid the foundation for our understanding of the universe and the climate. But his journey was not smooth. It was fraught with resistance, skepticism, and outright rejection by the very scientific community he sought to enlighten. Galileo's support for the heliocentric model of the solar system, which posited that the Earth and other planets revolve around the Sun, was revolutionary. It challenged the long-held geocentric view endorsed by the Catholic Church, which placed Earth at the center of the universe. Despite his rigorous observations and compelling evidence, Galileo faced intense opposition. His findings were seen as heretical, and he was eventually tried by the Inquisition and placed under house arrest for the remainder of his life. It serves as a stark reminder that scientific progress is often met with resistance, not because the evidence is lacking but because it challenges established beliefs and threatens the status quo. Galileo's plight underscores the importance of open inquiry and the willingness to question even the most deeply entrenched ideas. As we navigate the complexities of climate science today, we must remain vigilant against the same kind of bias that once stifled Galileo. True scientific inquiry demands that we follow the evidence wherever it leads, without fear or prejudice. Only then can we hope to understand the full tapestry of our planet's climate and our place within it. Galileo's story is not just a tale of scientific discovery, it is a testament to the enduring power of truth. Despite the immense obstacles he faced, Galileo's ideas eventually triumphed. Today, his name is synonymous with the courage to seek the truth, no matter the cost. In our quest to understand climate change, let us draw inspiration from Galileo's unwavering and relentless pursuit of knowledge. One of the most influential figures in the history of climate science was Svante Arrhenius, a Swedish scientist. In 1896, he published a groundbreaking paper that attempted to quantify the relationship between CO2 and global temperature. Arrhenius, drawing on the work of Tyndall, developed a simple equation. This equation predicted the extent to which doubling CO2 concentrations in the atmosphere would lead to global warming. Arrhenius's equation, while based on Tyndall's heating effects in a glass tube, provided a crucial framework. It highlighted the potential impact of CO2 emissions on a global scale. However, Arrhenius himself did not view increased CO2 as a threat. In fact, he believed that a warmer climate would be beneficial for humanity. He thought it would lead to increased agricultural productivity and more hospitable living conditions in colder regions. Despite Arrhenius's relatively optimistic outlook, his work laid the groundwork for future generations of scientists. They claimed that CO2 is a greenhouse gas and should be controlled. But Earth is no glass box. Earth has oceans, the sun, an ecosystem, clouds, and many other variables added to the equation. While Arrhenius's equation provided a useful starting point, it quickly became clear that the relationship between carbon dioxide and climate was far more complex than initially thought. Earth's climate is a delicate balance of interconnected systems, influenced by a multitude of factors, both natural and anthropogenic. One of the most significant natural drivers of climate change is the variation in the amount of solar radiation received by the Earth. These variations, caused by subtle changes in Earth's orbit and tilt, operate over vast timescales, driving the glacial and interglacial cycles that have shaped our planet for millions of years. In addition to these long-term cycles, Earth's climate is also influenced by shorter-term fluctuations in solar activity, volcanic eruptions, and ocean currents. Volcanic eruptions, for instance, can release massive amounts of carbon dioxide and other aerosols into the atmosphere, temporarily cooling the planet. Ocean currents, driven by wind and differences in temperature and salinity, play a crucial role in distributing heat around the globe, influencing regional and global climate patterns. As our understanding of Earth's climate system has evolved, so too has our appreciation for the complexity of the climate change issue. While there is no doubt that human activities, particularly the burning of fossil fuels, have contributed to the increase in atmospheric carbon dioxide, the magnitude of this impact and its consequences for the planet remain a subject of ongoing scientific debate. Some scientists, like Dr. Soon and Dr. Lindzen, argue that the recent warming trend is largely within the range of natural variability, driven by factors such as solar activity and ocean cycles. They point to the fact that the Earth has experienced periods of warming and cooling throughout its history, long before humans began burning fossil fuels. Most scientists maintain that the rate and magnitude of the current warming trend are unprecedented in human history, and that the increase in atmospheric carbon dioxide is the primary driver of this change. The debate over the causes and consequences of climate change is complex and multifaceted with no easy answers. It is essential that we approach this issue with a critical and discerning mind, carefully evaluating the evidence and avoiding simplistic explanations. The future of our planet may depend on our ability to have a reasoned and informed discussion about this crucial issue. In the vast expanse of our solar system, one celestial body reigns supreme, dictating the rhythm of life on our planet, the Sun. This colossal ball of plasma, a seething cauldron of nuclear fusion, bathes the Earth in a constant stream of energy, a life-giving torrent that dwarfs any other energy source on our planet. The Sun's influence on Earth's climate is undeniable, its energy driving the very processes that make our planet habitable. To comprehend the Sun's dominant role in shaping Earth's climate, we must first grasp the sheer magnitude of its energy output. Every second the Sun unleashes an unimaginable amount of energy, equivalent to the detonation of billions of atomic bombs. Only a tiny fraction of this energy reaches Earth, yet it's this minuscule fraction that powers our atmosphere, drives our weather patterns, and sustains all life on our planet. The total output from the Sun is a whopping 340 watts per square meter. Carbon only adds 91 watts. That's right, only a teensy 0.5% of the total warming. The Sun, far from being a static energy source, exhibits its own rhythm, a cyclical ebb and flow of activity that has a profound impact on Earth's climate. One of the most well-known of these cycles is the Schwab 11-year solar cycle, characterized by periodic increases and decreases in the number of sunspots, solar flares, and other forms of solar activity. Sunspots, those dark, cooler regions on the Sun's surface, are indicators of intense magnetic activity. During periods of high sunspot activity, the Sun emits more energy, including increased ultraviolet radiation, which can have a noticeable impact on Earth's upper atmosphere. Solar flares, sudden bursts of energy from the Sun's surface, can also influence Earth's climate, albeit in more indirect ways. These powerful eruptions can disrupt Earth's magnetic field, leading to geomagnetic storms that can interfere with radio communications and even damage satellites. The Sun's influence on Earth's climate extends far beyond its direct energy output. Our star also plays a crucial role in modulating the flux of cosmic rays, high-energy particles from deep space that constantly bombard our planet. These cosmic rays, originating from distant supernovae and other energetic events in the cosmos, can influence cloud formation in Earth's atmosphere. Clouds, those fluffy white masses that drift across our skies, play a critical role in Earth's energy balance. They act as both blankets and mirrors, reflecting sunlight back into space and trapping heat near the surface. Changes in cloud cover, even small ones, can have a significant impact on Earth's temperature. Cosmic rays, when they collide with molecules in Earth's atmosphere, can ionize those molecules, creating charged particles that act as condensation nuclei for cloud formation. During periods of high solar activity, the Sun's magnetic field acts as a shield, deflecting cosmic rays away from Earth. This reduction in cosmic rays leads to less cloud formation, allowing more sunlight to reach the surface, contributing to warming. When comparing the heating influence of water vapor to carbon dioxide, the ratio is approximately 30-1. Ever notice on a hot day in the sun when a cloud passes by shading you from the sun, how it instantly becomes cooler? While CO2 is often portrayed as the primary driver of runaway climate change, its actual warming effect is relatively small compared to the sun's overwhelming influence. The atmosphere's ability to absorb infrared radiation, the type of radiation that CO2 is particularly good at trapping, is not infinite. As CO2 concentrations increase, the atmosphere's ability to absorb additional infrared radiation diminishes. This phenomenon, known as saturation, means that each additional molecule of CO2 added to the atmosphere has a progressively smaller warming effect. At current CO2 concentrations, the atmosphere is already absorbing a significant portion of the infrared radiation emitted by the Earth's surface. Adding more CO2 will have a diminishing impact on the Earth's energy balance. The relationship between CO2 concentration and its warming effect is not linear but logarithmic. This means that doubling CO2 concentrations will not double the warming effect. Instead, each doubling of CO2 will result in a smaller and smaller incremental increase in temperature. Earth's climate is a delicate balance of interconnected systems influenced by a multitude of factors and random events. The sun, with its immense energy output and cyclical variations, plays a dominant role in shaping our planet's climate. While carbon dioxide has undoubtedly an effect, it is relatively small compared to the sun's overwhelming influence. Understanding the complex interplay of factors in Earth's climate is crucial for making informed decisions about our environmental future. We must move beyond simplistic narratives that demonize carbon dioxide and recognize that other factors play a dominant role in shaping our planet's climate. Nature decides the baseline for the temperature. Humans only influence the margins with a few degrees. Our planet engages in a celestial ballet, governed by the gravitational pull of the sun, the moon, and the planets in our solar system. This cosmic choreography, known as Milankovitch cycles, involves variations in Earth's orbit and tilt, impacting our climate. These cycles, spanning tens of thousands to hundreds of thousands of years, influence solar radiation distribution, altering seasons and climate patterns. Imagine Earth's orbit as an ellipse, its shape changing over millennia. This variation in eccentricity affects Earth's distance from the sun, influencing solar energy received. Superimposed on this dance is Earth's axial tilt, or obliquity, responsible for our seasons. Current obliquity makes for high variations in seasons' temperatures. The Milankovitch cycles have shaped Earth's climate over millennia, driving glacial and interglacial periods. During glacial periods, vast ice sheets cover large portions of the northern hemisphere, lowering sea levels. These periods, lasting tens of thousands of years, are punctuated by warmer interglacial periods like the one we're in now. The timing of these cycles is linked to the Milankovitch cycles, particularly eccentricity, influencing summer sunlight at high latitudes. When Earth's orbit is more elliptical, summers at high latitudes receive less solar radiation, leading to cooler temperatures and ice sheet growth, shown by Kepler's law. Conversely, a more circular orbit results in warmer summers, promoting ice sheet melt and interglacial conditions. Currently, we are in a low elliptical period. The axial tilt is 23.4 degrees, and the northern hemisphere summer solstice aligns with Earth's closest approach to the sun. The oceans, covering over 70% of Earth's surface, regulate our climate, acting as heat sinks and carbon reservoirs. They absorb and store vast amounts of heat from the sun, moderating global temperatures and influencing weather patterns. Oceans also play a critical role in the global carbon cycle, absorbing and releasing carbon dioxide. The ocean's ability to absorb CO2 is influenced by temperature, salinity, and ocean currents. Warmer water holds less dissolved gases, including CO2, similar to a heated carbonated beverage. As ocean temperatures rise, they can release stored CO2 back into the atmosphere. This release can amplify warming trends, acting as a positive feedback mechanism. This enriches the atmosphere with nutrients. Fueling life, energizing the atmosphere, and greening the planet. Volcanic eruptions, awe-inspiring displays of Earth's inner fury, shape our planet's climate. These eruptions inject massive amounts of particles and gases into the atmosphere, influencing Earth's energy balance. Volcanic emissions include water vapor, carbon dioxide, sulfur dioxide, and ash particles. The impact on climate depends on the eruption's size, duration, and chemical composition. Large eruptions can inject sulfur dioxide into the stratosphere, forming sulfate aerosols. These aerosols reflect sunlight, cooling the planet. The 1991 eruption of Mount Pinatubo injected 20 million tons of sulfur dioxide, causing a noticeable dip in global temperatures. Volcanic eruptions, while destructive, play a significant role in regulating Earth's temperature. Earth's climate is influenced by many interconnected factors, natural and man-made. Milankovitch cycles have shaped our climate over millennia, driving glacial and interglacial periods. Oceans act as buffers against rapid climate change, absorbing and storing heat and CO2. Volcanic eruptions inject particles and gases into the atmosphere, temporarily cooling the planet. Understanding these natural climate drivers is essential for putting human-induced climate change into perspective. Human activities only have a small part to play in the overall. Earth's natural deposits still count for 97% of CO2 release in the atmosphere. Carbon dioxide, often demonized, is fundamental to life. Carbon is the building block of all living organisms, forming proteins, carbohydrates, and DNA. Plants convert CO2 into energy-rich sugars through photosynthesis. This process forms the foundation of most ecosystems, providing energy for all life forms. CO2 enters leaves, combines with water, and transforms into glucose, fueling plant growth. Photosynthesis releases oxygen, replenishing the air we breathe. Historically, CO2 levels were much higher, ranging from 1,000 to 2,000 ppm. These elevated levels of CO2 supported lush vegetation and thriving ecosystems. Higher CO2 levels can enhance plant growth, leading to more robust ecosystems. Understanding CO2's role helps us appreciate its importance in sustaining life on Earth. Rising CO2 levels have led to a remarkable transformation. Earth is getting greener. Studies show increased plant growth and vegetation cover, especially in arid regions. This phenomenon, known as carbon dioxide fertilization, occurs because plants thrive when resources are abundant. CO2 is essential for plant growth, used in photosynthesis. As CO2 levels rise, plants photosynthesize more efficiently, leading to increased growth. Larger leaves and more extensive root systems result. This global greening trend is often overlooked in climate change narratives. In fact, humans already utilize higher CO2 levels in greenhouses to boost crop yields. By enriching the air with CO2, we can achieve faster growth and higher productivity in our crops. During ancient times, CO2 levels were far higher than today, even up to 10,000 ppm in the early stages of life before plants even evolved. This carbon-rich atmosphere fueled an explosion of life. Lush jungles teemed with giant ferns, towering trees, and diverse animals. The fossil record shows this ancient abundance, a testament to CO2's life-giving power. High CO2 levels supported massive plant growth and influenced plant evolution. Plants evolved efficient photosynthetic pathways, thriving in this rich environment. These high concentrations of CO2 never resulted in a runaway climate. Carbon dioxide is integral to Earth's life support system. Carbon flows through the biosphere, connecting all living things. The carbon cycle involves continuous carbon exchange between the atmosphere, oceans, land, and organisms. Plants absorb CO2 during photosynthesis, releasing it when they decompose. Animals obtain carbon by consuming plants or other animals, releasing CO2 through respiration. Understanding the carbon cycle's intricacies is crucial for informed environmental decisions. We must move beyond simplistic narratives and recognize CO2's essential role. Embracing a nuanced approach to climate science ensures a healthy planet for future generations. Life adapts and thrives in the face of environmental change. Throughout Earth's history, life has endured dramatic shifts in climate, sea level, and atmospheric composition. Life has flourished, adapting to meet changing world challenges. This resilience stems from the capacity for adaptation, adjusting to the environment over time. Natural selection favors individuals best suited to their environment. Traits enhancing survival and reproduction are passed on, shaping species characteristics. This adaptation process is evident in Earth's incredible diversity of life. From polar bears to cacti, life finds ways to thrive in extreme environments. In the deep sea, bioluminescent fish and organisms near hydrothermal vents showcase resilience in the absence of sunlight. Tardigrades capable of surviving extreme conditions, desert beetles, penguins in Antarctica, and camels in the Sahara all exemplify nature's adaptability. High-altitude birds, mountain goats, and alpine plants thrive in thin air and cold temperatures, demonstrating remarkable resilience. Even in volcanic regions, acidic lakes, and toxic environments, life finds a way to adapt and survive. The resilience of life is a testament to nature's incredible adaptability and the enduring spirit of survival. Polar bears, iconic for being the example for climate change, face challenges from shrinking sea ice. These apex predators are not passive victims, they are masters of survival. Polar bears thrive in harsh environments with adaptations like thick fur and blubber. Their large paws provide traction on ice and snow. While sea ice loss is a concern, polar bears are opportunistic feeders. They consume various prey including seals, walruses, birds, and vegetation. Polar bears swim long distances between ice floes and scavenge on land. They demonstrate adaptability and resilience in the face of environmental change. Polar bears' survival skills highlight their ability to thrive despite challenges. Their story is a testament to the adaptability of life. Polar bears have a long, evolutionary history, dating back 600,000 to 1.2 million years. They have survived ice ages and warm periods with remarkable ease, showcasing their resilience. Coral reefs, often depicted as the rainforests of the sea, have been the focus of alarmist claims regarding bleaching events and their potential demise. While it's true that coral reefs face significant challenges, it's crucial to understand the complexity and resilience of these ecosystems. Corals rely on a symbiotic relationship with tiny algae called zooxanthellae, which live within their tissues and provide them with energy through photosynthesis. This relationship is influenced by various factors including water temperature and CO2 levels. Contrary to popular belief, CO2 plays a vital role in the health of coral reefs by contributing to their calcification process. Bleaching events occur when corals expel their symbiotic algae due to stress, often caused by elevated water temperatures. However, these events are not necessarily a death sentence for coral reefs. In many cases, corals have shown remarkable recovery and adaptation abilities. Recent studies have documented significant signs of recovery in various coral reefs around the world, highlighting their resilience. Ecosystems are dynamic and constantly evolving in response to environmental changes. Coral reefs are no exception. They have survived and adapted through numerous climate shifts over millions of years. While the challenges they face today are significant, it's essential to recognize their inherent capacity to adapt and thrive. By understanding the natural processes and resilience of coral reefs, we can foster a more balanced perspective on their future. Rather than succumbing to alarmist narratives, we can appreciate the adaptability of these extraordinary ecosystems and work towards supporting their recovery and conservation. In the grand tapestry of nature, coral reefs stand as a testament to life's ability to endure and flourish, even in the face of adversity. Invisible to the naked eye, a vast and diverse world of microorganisms teems with life, shaping the very foundations of Earth's ecosystems. These microscopic marvels, including bacteria, archaea, and protists, play essential roles in nutrient cycling, decomposition, and even climate regulation, influencing the planet's habitability in ways we are only beginning to understand. Bacteria in particular are masters of adaptation, thriving in virtually every environment on Earth, from the depths of the oceans to the heights of the atmosphere. They possess an astonishing genetic diversity, allowing them to metabolize a vast array of compounds, including pollutants and greenhouse gases, playing a crucial role in maintaining Earth's environmental balance. In the face of climate change, bacteria are proving to be remarkably resilient, adapting to changing temperatures, pH levels, and nutrient availability. Some bacteria, for instance, can utilize carbon dioxide as their sole carbon source, converting it into organic compounds through a process known as chemoautotrophy. It is estimated that microbes produce 45 to 75% of gross CO2 emissions. Measuring this is hard, and every year it changes. Still, they play a big part in the CO2 ecosystem. Remarkably, some bacteria have evolved to consume plastics, breaking down these persistent pollutants into simpler compounds. This discovery highlights the incredible versatility of life and its ability to adapt to new and challenging circumstances. These plastic-eating bacteria offer a glimmer of hope in addressing the global plastic pollution crisis. Their unique metabolic pathways are being studied to develop biotechnological solutions for waste management and environmental restoration. Life on Earth is a testament to the power of adaptation, a testament to the enduring ability of organisms to overcome adversity and thrive in the face of change. From the smallest bacteria to the largest whales, life has weathered countless environmental upheavals throughout Earth's history, adapting and evolving to meet the challenges of a changing world. While climate change undoubtedly poses challenges for many species, it's essential to remember that life is not static. It's a dynamic force constantly adapting and evolving to meet the demands of its environment. Species have migrated to new habitats, shifted their ranges, altered their behaviors, and even evolved new physiological traits to cope with changing conditions. Understanding the mechanisms by which life adapts to change, both in the past and present, is crucial for predicting the potential impacts of future climate change and for developing effective conservation strategies. By studying the resilience of life, we gain a deeper appreciation for the interconnectedness of Earth's ecosystems and the remarkable ability of life to persist and thrive in the face of adversity. The airwaves crackle with dire warnings. Images of flooded cities, parched landscapes, and raging wildfires flash across our screens, accompanied by pronouncements of impending climate catastrophe. Fear, it seems, has become the prevailing currency in the climate change debate, a powerful tool employed to galvanize public opinion, shape policy decisions, and silence dissenting voices. But who profits from this climate of fear? Who benefits from painting a picture of an inevitable apocalypse, a future defined by environmental devastation and societal collapse? Politicians, eager to appear proactive on what is arguably the defining issue of our time, leverage the language of crisis to justify sweeping policy changes, often with little regard for the economic and societal consequences. Environmental organizations, reliant on donations and public support, employ fear-mongering tactics to bolster their fundraising efforts, painting a picture of a planet on the brink of collapse, a crisis only they can avert. Fear, while a powerful motivator, can also be a blinding one, leading to rash decisions, misallocation of resources, and a stifling of open and honest debate. When fear becomes the dominant emotion, it becomes all too easy to dismiss alternative viewpoints, to silence dissenting opinions, and to embrace simplistic solutions to complex problems. In the annals of climate change alarmism, few images are as iconic or as controversial as the hockey stick graph. First published in the late 1990s, this graph purported to show a dramatic and unprecedented rise in global temperatures in the 20th century, a sharp uptick resembling the blade of a hockey stick. The implication was clear. Human activity, particularly the burning of fossil fuels, was driving the planet towards catastrophic warming. The hockey stick graph quickly became a centerpiece of the climate change movement, featured prominently in Al Gore's 2006 documentary, An Inconvenient Truth, and embraced by policymakers and environmental organizations worldwide as irrefutable evidence of human-induced climate change. However, the graph's seemingly unambiguous message masked a series of methodological flaws and data manipulation that would eventually undermine its credibility. Independent researchers, scrutinizing the data and statistical methods used to construct the hockey stick graph, uncovered a series of errors and omissions that cast serious doubt on its validity. They found that the graph's creators had cherry-picked data, ignored historical temperature fluctuations, and used flawed statistical techniques that exaggerated the recent warming trend. Few individuals have profited as handsomely from climate change alarmism as Al Gore, the former US vice president who reinvented himself as a climate change crusader. Gore, through his books, films, and speeches, has amassed a personal fortune estimated to be in the hundreds of millions of dollars, largely through his advocacy for climate action and his investments in green technology companies. While Gore's personal wealth may be a testament to his entrepreneurial savvy, it also raises uncomfortable questions about the motivations behind his climate change activism. Is Gore a sincere advocate for the environment, driven by a genuine desire to avert ecological disaster? Or is he a shrewd businessman capitalizing on public fear to line his own pockets? Gore's lavish lifestyle, including his multiple mansions, frequent private jet travel, and investments in companies that benefit from government subsidies and regulations, stands in stark contrast to the message of austerity and sacrifice he preaches to the public. This hypocrisy, often pointed out by his critics, undermines his credibility and fuels accusations that he is more interested in personal enrichment than in finding practical solutions to climate change. Bill Gates, the tech mogul turned philanthropist, has emerged as a prominent voice in the climate change debate. Gates has proposed a series of controversial solutions to tackle global warming. He has invested billions in CO2 solutions. One of the most contentious is geoengineering, deliberately altering the Earth's climate system to counteract the effects of climate change. This includes ideas like spraying aerosols into the atmosphere to reflect sunlight and cool the planet. Critics argue that such interventions could have unpredictable and potentially disastrous consequences. Gates has also turned his attention to agriculture, famously advocating for the reduction of methane emissions from cows. His foundation has funded research into creating synthetic meat alternatives and even genetically modifying cows to produce less methane. But perhaps most eyebrow-raising is his investment in companies that promote eating insects as a sustainable source of protein, a solution that has yet to gain widespread acceptance. In addition to his technological fixes, Gates has been buying up vast tracts of farmland across the United States, becoming one of the largest private owners of agricultural land in the country. This move has raised concerns about the consolidation of food production and the influence one individual can wield over an essential resource. Gates' stance on trees also sparks debate. While most environmentalists advocate planting trees to absorb CO2, Gates has argued that this alone won't be enough to solve the climate crisis. Instead, he has invested heavily in machines capturing carbon, technocratic surrogates for nature, sold by the wealthy and powerful. Critics say these technologies are unproven and divert attention from more straightforward solutions like reforestation. Despite his noble claims, Gates' ventures are not without financial incentives. His investments in green technologies and carbon capture solutions have the potential to yield significant returns. This dual role as both a benefactor and a beneficiary of climate solutions has led some to question his motives. Is Gates genuinely committed to saving the planet, or is he leveraging his influence to create profitable business opportunities? As with many high-profile figures in the climate debate, Gates' actions and motivations are complex and multifaceted. His story underscores the challenges of balancing innovation, ethics, and profit in the quest to address one of the most pressing issues of our time. The World Economic Forum and the United Nations Agenda 2030 have become focal points in the global climate debate. Spearheaded by Klaus Schwab, the WEF has introduced the concept of the Great Reset, a plan that aims to reshape economies and societies in the wake of the COVID-19 pandemic. Central to this agenda are sweeping changes purported to address climate change, economic inequality, and social justice. Klaus Schwab, an influential figure in global policy circles, envisions a future where governments and corporations work hand in hand to create a more sustainable and equitable world. However, critics argue that this vision masks a deeper agenda of centralized control and profit maximization for the elite. One of the most contentious aspects of this agenda is the push for carbon taxes. Proponents argue that taxing carbon emissions is a necessary step to reduce global warming and incentivize green technologies. Yet, skeptics warn that carbon taxes could disproportionately impact low-income communities and small businesses, while failing to address the root causes of environmental degradation. Adding to the controversy is the emergence of the new ruler in this narrative, the Nestlé boss. Nestlé, a multinational corporation with a checkered past, has been accused of exploiting natural resources for profit. The company's history is marred by allegations of unethical practices, such as over-extracting water in drought-stricken regions and contributing to deforestation. Nestlé's involvement in the global climate agenda raises questions about the true motivations behind these initiatives. Are they genuine efforts to combat climate change? Or are they opportunities for large corporations to consolidate power and control over essential resources? As we navigate these complex issues, it's crucial to remain skeptical and critically examine the actions and motivations of those at the helm. The intersection of climate policy, corporate interests, and global governance is fraught with challenges and contradictions. By questioning the narratives and seeking transparency, we can strive for solutions that genuinely benefit both people and the planet. While global climate change often captures headlines, it's the local environmental issues that truly illustrate the immediate impact of human activity. Corporations and governments play a significant role in these localized problems, often overshadowing the broader narrative of climate change. Consider deforestation. In many regions, vast tracts of forest are cleared to make way for agriculture, urban development, or logging. This not only destroys habitats but also accelerates biodiversity loss. Local fauna and flora, unable to adapt quickly enough, face extinction. Governments, incentivized by economic growth, often turn a blind eye or even support these activities, blaming the loss on climate change. Flooding is another pressing issue. Urban expansion and poor planning can exacerbate natural flood cycles, making them more frequent and severe. Construction on floodplains, inadequate drainage systems, and the destruction of wetlands all contribute to catastrophic floods. These are not always the result of climate change but of human choices and mismanagement. The introduction of invasive species is yet another example. When new species are brought into non-native habitats, either intentionally or accidentally, they can wreak havoc on local ecosystems. These species often outcompete native ones, leading to a decline in biodiversity. Or look at the wildfires, claimed to be climate-induced. Studies show most fires are human causes, from camping to even psychotic people starting them on purpose. Governments save money by cutting on forest maintenance, making money by letting companies dry out areas with forestation. Many factors play a role. These issues are compounded by human actions. For instance, multinational corporations often exploit natural resources with little regard for local communities or ecosystems. Governments eager to attract investment may offer lax regulations and oversight, further exacerbating environmental degradation. It's crucial to recognize that these local problems are often the root causes of biodiversity loss and environmental degradation. Many times climate change is the scapegoat used to steer direction away from corporations and government choices. Effective solutions must address the actions of corporations and governments at the local level, rather than placing all the blame on global climate phenomena. By understanding and addressing these root causes, we can make significant strides in preserving biodiversity and protecting our environment. It's a complex web of interactions, but with transparency and accountability, we can work towards a more sustainable future for all. In the world of climate science, predictions are often made with intentions most never come to pass. Take, for instance, the alarming forecasts of rising sea levels that were supposed to submerge coastal cities by now. While sea levels have indeed risen, the catastrophic scenarios painted by some have not materialized. Similarly, the prediction of boiling seas and an increase in deadly storms has not matched the reality we've observed. Politicians and corporations often leverage these dire predictions to advance their own agendas. The narrative of impending doom can be a powerful tool for enacting policies and regulations that might otherwise meet with resistance. For example, the constant drumbeat of alarmism has been used to justify substantial investments in renewable energy technologies, which, while beneficial on a small scale, also come with their own set of environmental issues. Solar panels and wind turbines can lead to deforestation, wildlife destruction, have low durability, and involve high production costs. Additionally, they can be unreliable energy sources when the sun isn't shining or the wind isn't blowing. Wind turbines have a lifespan of 15 to 20 years, and their blades, which are not recyclable, often end up buried underground. Solar panels can leak heavy metals and destroy landscapes. The 1.5-degree narrative, a benchmark set to avoid catastrophic climate impacts, has been a rallying cry for many. However, critics argue that this target is not based on solid scientific consensus, but rather on political expediency. Who decides what is the right temperature? The fear-mongering associated with surpassing this threshold has become a means to push for drastic measures that will take sacrifices, as the media tells us. Alarmism and fear-mongering serve a dual purpose. They not only galvanize public support for urgent action but also create lucrative opportunities for certain sectors. The financial and political elites are often the ones who stand to benefit the most from these narratives. By fostering a sense of imminent crisis, they can push through policies and investments that align with their interests, all while presenting themselves as saviors of the planet. So-called philanthropists use government money via NGOs they create, so-called good causes, generating billions of dollars. Understanding the motivations behind these narratives allows us to discern genuine efforts to combat climate change from those driven by profit and control. The intersection of climate science, politics, NGOs, and corporate interests is a complex and often murky territory. By seeking transparency and questioning the motivations of those in power, we can work towards solutions that truly benefit both humanity and the environment. In 2007, a group of climate scientists predicted that the Arctic Ocean could be ice-free during the summer months by 2013, a mere 6 years later. This dire prediction, based on computer models that overestimated the rate of sea ice melt, made headlines worldwide, fueling fears of an imminent climate tipping point. However, the predicted ice-free Arctic never materialized. While Arctic sea ice extent has declined in recent decades, it has not disappeared at the rate predicted by the models. In fact, in recent years, Arctic sea ice extent has stabilized, and some regions have even shown modest growth. The failure of this and other alarmist predictions to materialize highlights the limitations of climate models, particularly their tendency to overestimate the rate and magnitude of future warming. Climate models, while useful tools for understanding complex systems, are not crystal balls. They are based on a multitude of assumptions and simplifications, and their projections are only as good as the data and understanding of the climate system that go into them. The history of temperature measurements is a tale of evolving technology and expanding human footprint. Initially, temperature data was collected from remote and rural locations, providing a more natural and undisturbed record of Earth's climate. However, as the world urbanized, many of these measurement stations found themselves surrounded by concrete jungles, airports, factories, buildings, electrical wiring, lamps, and machines. Urbanization has a profound impact on temperature readings. Asphalt, buildings, and other human-made structures absorb and retain heat, leading to what is known as the urban heat island effect. This phenomenon can cause temperature readings in urban areas to be significantly higher than those in rural locations. Many temperature measurement stations are now situated near these heat-trapping environments, skewing the data and painting a warmer picture of the climate than might be accurate. Airports in particular are hotspots for temperature measurement bias. The vast expanses of tarmac and the constant activity of aircraft and vehicles create localized warming that can distort temperature records. Similarly, factories and industrial areas generate heat through their operations, further contributing to the urban heat effect. This skewing of data raises important questions about the accuracy of temperature records used in climate science. Many studies seem to exaggerate heating, not showing these urbanization effects. Understanding the impact of urbanization on temperature measurements is crucial for developing a more accurate picture of our planet's climate and for making informed decisions about the future. By acknowledging and addressing these challenges, we can strive for a more precise and reliable understanding of climate trends, free from the distortions introduced by our own constructed environments. The 97% consensus narrative is often cited as definitive proof of scientific agreement on climate change. However, this figure is not as clear-cut as it seems. Many of the studies contributing to this percentage are funded by governments and corporations with vested interests in promoting a specific outcome. The origins can be traced back to John Cook, which looked at thousands of studies and asked the question, is there any human influence on climate? The 2013 study behind this stretched vague abstracts to fit a narrative, used studies that even claimed mostly nature as proof humans cause climate change. The study used a very broad definition to fit the narrative. Moreover, the funding sources behind these studies play a significant role in shaping their outcomes. Governments and corporations with vested interests in climate policy and energy markets often fund research that aligns with their agendas. This creates a potential bias in the scientific literature, as researchers may feel pressured to produce results that support the prevailing narrative in order to secure future funding. It's crucial to approach the 97% consensus figure with a healthy dose of skepticism and to question the motivations behind the funding. This study could be replicated using the same methodology with the opposite conclusion. Claim it is mostly natural caused, use the definition as broad as possible. The outcome will be the same. Science, in its purest form, is a noble pursuit, a quest for knowledge and understanding driven by curiosity, skepticism, and a commitment to evidence-based inquiry. However, in the real world, science is often influenced by factors that have little to do with the pursuit of truth, factors such as funding pressures, political agendas, and the desire for career advancement. In the field of climate science, billions of dollars in research funding are available to those who can demonstrate the human causes and catastrophic consequences of climate change. This funding bias, while understandable given the political salience of the issue, creates a perverse incentive structure that rewards alarmist findings and discourages research that challenges the prevailing narrative. Scientists, like anyone else, are not immune to the allure of financial security and professional recognition. Those who depend on research grants to fund their work and advance their careers may be reluctant to pursue research that could jeopardize their funding or damage their reputations. This creates a chilling effect on scientific inquiry, discouraging dissent and stifling debate on one of the most critical issues facing humanity. As our journey through the complex and often contentious landscape of the carbon dioxide debate draws to a close, it's essential to step back and reflect on the key insights gleaned from our exploration. We've ventured beyond the headlines and the sound bites, beyond the alarmist rhetoric and the fear-mongering, to uncover a more nuanced and evidence-based understanding of the relationship between carbon dioxide, climate change, and the future of our planet. The picture that emerges is not one of impending doom, but rather one of complexity, adaptation, and the enduring power of nature. We've seen how carbon dioxide, often demonized as a pollutant, is in fact an essential component of Earth's life support system, a fundamental building block of life that has fueled the greening of our planet and the abundance of ecosystems for millennia. We've explored the intricate workings of Earth's climate system, a dynamic interplay of solar radiation, ocean currents, volcanic activity, and natural climate cycles that have driven periods of warming and cooling long before humans entered the scene. And we've examined the limits of climate models, those complex computer simulations that, while useful tools for understanding climate dynamics, are often misused to generate alarmist projections that fail to materialize. Throughout our exploration, we've encountered a consistent theme: the importance of approaching the climate change issue with a critical and discerning mind, questioning assumptions, challenging dogma, and embracing scientific rigor over emotional appeals. The human mind, with its innate desire for order and predictability, is naturally drawn to simple explanations, to narratives that offer clear cause and effect relationships and readily identifiable villains. In the case of climate change, the narrative that has taken hold is one that casts carbon dioxide as the primary antagonist, a dangerous pollutant driving the planet towards irreversible warming. This narrative, while appealing in its simplicity, fails to capture the true complexity of Earth's climate system, a system shaped by a multitude of interacting factors. Human interaction is just playing a small cog in the machine. The truth, as we've discovered, is far more nuanced. Carbon dioxide is just part of the ecosystem, one actor in a far grander play, a play with a cast of characters and a plot far more intricate than we can currently comprehend. Solar activity, volcanic eruptions, ocean cycles, and even the subtle wobbles in Earth's orbit all exert their influence on our planet's climate, sometimes amplifying, sometimes mitigating the impact of human activities. To fully comprehend the climate change issue, we must resist the allure of simplistic explanations and embrace the messy reality of a complex and dynamic system. We must acknowledge the uncertainties inherent in climate science, the limitations of our models, and the humbling vastness of what we still don't know. Only then can we hope to develop effective and sustainable solutions that address the real challenges posed by a changing climate. At the heart of any scientific endeavor lies a fundamental commitment to the scientific method, a rigorous process of observation, hypothesis testing, and evidence-based inquiry. The scientific method, with its emphasis on skepticism, peer review, and the open exchange of ideas, has been the driving force behind countless discoveries and technological advancements, propelling humanity forward for centuries. Yet, in the politically charged arena of climate change, the scientific method is often sidelined, its principles disregarded in favor of predetermined conclusions and ideologically driven agendas. We've seen how alarmist claims, often based on flawed data, cherry-picked evidence, and exaggerated projections, are routinely presented as irrefutable truths, their proponents immune to scrutiny or dissenting viewpoints. We've witnessed the silencing of dissenting voices, the marginalization of scientists who dare to question the prevailing dogma, and the suppression of research that challenges the dominant narrative. To reclaim the integrity of climate science, we must return to the foundational principles of the scientific method. We must encourage open inquiry, welcome dissenting viewpoints, and demand rigorous evidence to support all claims. The pursuit of truth, not the advancement of political agendas or the accumulation of personal wealth, must be the guiding principle of climate science. The climate change debate, with its high stakes and far-reaching implications, has become a battleground for competing ideologies, a breeding ground for fear, and a tool for political manipulation. In this polarized environment, open and honest dialogue has become increasingly rare, replaced by a cacophony of accusations, insults, and ad hominem attacks. Those who dare to question the prevailing narrative are often labeled as deniers, their motives impugned, and their voices silenced. This stifling of debate is not only antithetical to the spirit of scientific inquiry, but it's also counterproductive to finding effective solutions to the challenges posed by a changing climate. To move forward, we must foster a climate of open inquiry, where diverse perspectives are welcomed, dissenting viewpoints are respected, and evidence, not ideology, is the ultimate arbiter of truth. We must create spaces where scientists, policymakers, business leaders, and concerned citizens can engage in respectful dialogue, challenge assumptions, and explore a range of solutions. The climate change issue is far too important to be held hostage by dogma, fear, or political expediency. It demands our collective wisdom, our willingness to listen and learn from one another, and our commitment to finding common ground. As we embrace open inquiry and scientific exploration, we unlock the potential for a brighter, greener future. Imagine a world where CO2 and biotechnology are harnessed not as threats, but as powerful tools for transformation. In this warmer, CO2-rich environment, we can cultivate a new Garden of Eden, teeming with diversity and life. Science, unshackled from fear and dogma, offers us the keys to integrate humankind and our ecosystems into these new realities. Advances in biotechnology could revolutionize agriculture, allowing us to grow more food with less land, and reducing our impact on natural habitats. Enhanced CO2 levels could boost plant growth, leading to lush forests and vibrant landscapes that support a myriad of species. This vision is not just a dream, it's a call to action. By fostering a spirit of innovation and collaboration, we can reimagine our relationship with the planet. We can build resilient communities that thrive in harmony with nature, where clean energy powers our cities, and sustainable practices restore the balance we've disrupted. Let us be positive about the future and trust in the power of science to guide us. Together, we can create a world where both humanity and the environment flourish, a testament to our capacity for ingenuity, and our commitment to stewardship. The path forward is clear: embrace the possibilities, celebrate the diversity of life, and work towards a sustainable, thriving planet for generations to come. Proof shows that a thicker atmosphere can be beneficial for life, creating conditions where ecosystems can thrive. If we just go with the flow, we can adapt and flourish. Let's use climate change to our advantage and embrace the change. Together, we can turn challenges into opportunities and create a future where we all thrive.